Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and I'm joined tonight by Sana Withers. We are broadcasting live from the somewhat snowy Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. Just as a reminder, York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at 2 a.m. UT if you are looking to convert time zones. The York Universe production works in concert with our amazing online public viewing program run by the Observatory team, which runs from the exact same hours from 9 to 10 p.m. local Toronto time. If you are trying to find out about our old episodes or just navigate to our show at any given point in time, you can always find us at yorku.ca/science/observatory. Follow the links to OPV online public viewing, or click on any link that says YouTube, and it will take you to our YouTube channel where all the fun happens. You can join the live chat if you're listening live, and of course, you can always replay your favorite episodes. If you have any questions or comments about our past shows or suggestions for future topics, you can email us at observe@yorku.ca. And always you can find us on most of the media channels. We're on Instagram, Yorku Observatory, Twitter, York Observatory, no you, and York Universe, and of course Facebook at Allan Carswell Obs. All of our programs are free, but if you would like to make a donation, you can always see our website, yorku.ca/science/observatory. Our crew is monitoring the chat room for your astronomy questions, so please feel free to join in on YouTube. As mentioned before, the current weather is very much blah. It has been very cloudy, and Sana, I'm guessing it's not peeking any stars out where you are either.
Oh, no, no. Terrible clouds here too.
I have to say, having now been through a few winters in Toronto, this is extremely cloudy. We have had very few breaks in the clouds at all in the last 2 weeks, which has made it really, really hard to plan solid observing runs. I think theoretically it was probably possible to maybe sneak the domes open for an hour somewhere around 3 a.m. on one of those days. But yeah, it has been very tough, even with a wonderful robotic telescope. Um, but
Yeah,
hope springs eternal, and every day is another chance, or I should say night. We still have a
yeah,
lot of long nights in January to help make us up for all that lost data.
yeah. I need to get every second out of the clear skies as we can for the next month or so.
Absolutely. Well, and as you mentioned before, we were talking when they're getting ready for the show, is we do have a robotic observatory which has several emergency closed conditions. One of the most important is water. However, in Toronto, it's cold enough. The water is not a liquid; it actually is a solid, and when it is ice, solid enough. Sensors actually can't detect it on the telescope, which makes it a little more tricky in those winter months to do some of the remote action. So we are looking forward to some clear, non-snowy nights where we can safely open up and plan some robotic fun for the telescope
hmm
or
So not a
telescope.
very,
Oh, go
yeah,
ahead.
not a very, sorry, not a very good, I guess, astronomy start to 2024 so far.
Well, not a very good number of observations that we've been able to
Yeah.
do. There have been some really cool things happening because there's always something happening up there, which is what I love about astronomy. It's, every night there's something new going on somewhere in the sky. Whether or not we can see it is the optimal question.
Yeah. Somebody always has clear skies, so I guess it's kind of comforting is that somebody's always observing, even if we're not.
Yeah, we just need to make more friends with more different robotic observatories, and one of us will always have a clear night. But speaking of things you need telescopes to see, I suppose this navigates us over to one of our first This Week in Space and Astronomy History for the new year of 2024. I suppose if you go by Julian date, it's not really very interesting. But on our calendar, it is a new year. It's a new January. And if we go back, well, quite a ways, there's some interesting discoveries that you have on your list, Sana.
Yeah. So for the first item, we'll be going all the way back to 1787 on January 11th, when two new moons of Uranus were discovered, which are now named Tatiana and Oberon. I think I'm pronouncing those correctly, so please correct me if I'm not. But both of these moons were discovered by astronomer William Herschel. He's credited with a whole bunch of interesting and fascinating discoveries in astronomy, including the discovery of Uranus itself. So William Herschel did a lot of the pioneering work in studying Uranus and its entire moon systems. So Tatiana and Oberon, the two moons that William Herschel discovered, are the two largest moons of Uranus. Tatiana is the largest, and then Oberon is the second. They also both place in the top 10 list of the largest moons in our solar system. So they're definitely some very interesting objects. So this was not known at the time, but it's now known that Uranus does have five major moons. Of course, Tatiana and Oberon, being the two largest moons of Uranus, are part of the five major moons of Uranus. All of these moons are believed to have formed out of the same stuff at the same time. In particular, they formed out of this accretion disk, so this disk of material that had been orbiting Uranus not long after it formed. Eventually, different particles in this accretion disk started to kind of clump together with gravity and grew into the five major moons. Now, because all of the moons formed out of the same stuff, they have a lot of the same composition and some kind of similar properties. They're all mainly composed of half ice and half rock, and are all kind of have this grayish sort of appearance, but it's not always perfectly gray. So apart from sharing the same composition and some kind of similar colors, each of the moons does have its own unique features. So starting off with Tatiana, it's likely a geologically active moon. When the Voyager 2 probe did flybys of the Uranus and Neptune systems, and I think it was the 1980s, it did provide some kind of up-close views of the moons of these systems, including Tatiana and Oberon, which are some of the most detailed observations that we do have of those moons. It revealed Tatiana, one side of it anyways, to have a lot of like this really intricate system of kind of fault valleys and canyons and other things on the surface, including a fault valley, which is about 1,600 kilometers long. A lot of these features were likely formed kind of later in the evolution of Tatiana, when the interior actually expanded and created some of these fault systems and canyons and valleys on the surface. In terms of Oberon, it also does have some kind of canyon systems, but in contrast to Tatiana, it's nowhere near as extensive as Tatiana. So it does have them, but it's just nowhere near as much. Both Tatiana and Oberon also have a lot of craters, but again, they're slightly different. Oberon is very, very heavily cratered. It's actually the most heavily cratered of the five major moons of Uranus, which means that its surface is quite old. So its surface has had more time to have more collisions and accumulate a lot of these craters. Tatiana has a lot of craters as well, but in comparison to Oberon, it has fewer, which indicates that the surface is young. Again, this is likely the result of some kind of geological activity where the surface used to have more craters, but some of those craters got wiped out during some geologic activity and created this kind of younger surface that doesn't have as many craters. And another really cool thing about Oberon, which I'd never heard of a moon being able to do this before, is Oberon is actually the reddest of all of the five major moons of Uranus. If you look at pictures of it, it does have a kind of reddish tint to it. And really interestingly, the leading hemisphere of Oberon is actually redder than the trailing hemisphere, which is likely caused by red material sort of accreting to the surface of Oberon. All of this red material is sort of crashing onto the surface as it moves in its orbit, which makes the leading hemisphere redder than the trailing hemisphere, which I think is a really cool feature of Oberon. Now, in addition to the interesting features of Tatiana and Oberon, if we go back to 1852, before all of this information about the moons was known, The moons of Uranus have some very interesting names. The names were decided by astronomer William Herschel's son John Herschel in 1852. By that point, a different astronomer, William Lassell, had discovered two additional moons of Uranus, which were now called Ariel and Umbriel. And when John Herschel decided to name these four known moons of Uranus at the time, he decided to name them after spirits and creatures in English literature. So the moons Oberon and Tatiana were fairies that appeared in Shakespeare's play A Midsummer Night's Dream. And then the other two moons that have been discovered by William Lassell were named Ariel and Umbriel, which are two things that appear in Alexander Pope's poem The Rape of the Lock. And Ariel was also a spirit that appeared in Shakespeare's play The Tempest. So this is kind of in contrast to the way that a lot of things in our solar system are currently named. Most of them are chosen as characters coming from Greek mythology. But the International Astronomical Union did actually decide to stick with the naming convention started by John Herschel in 1852, and they have continued to name all of the moons of Uranus after characters in Shakespeare's play, and also characters that appeared in Alexander Pope's poem.
Yeah, it's so interesting the history of not just the discovery, but also how they sort of sort of stumbled around the names, especially Uranus, because as we've mentioned before on this show, that isn't what William Herschel wanted to call the planet. Of course, he wanted to call it St. George's planet, which would not abide by the French because that was an English royalty. But I think it took like, was it 10 or 20 years or longer for them to actually officially change the name on purpose to Uranus. Which has been mentioned. It's changed from Georgium Sidus to Uranus. So it was it 82? Yeah, it was more than 50 years actually, more than 50 years for them to actually make the change, because it went well with the Roman gods, because of course you already had Jupiter and Saturn, and which went along with the Latinized versions of Greek gods. But the actual Latinized version of the actual Greek god isn't Uranus, it's Uranos. And so the actual name that they were going for was Uranos, and they changed it. They sort of modernized it to be Uranus. And actually, since then, there have been several attempts to put forth that its actual Roman equivalent would be Caelus, which I mean sounds kind of like a very famous Klingon from Star Trek, but it's spelled Caelus, and it sounds awesome. And it's the actual Roman equivalent, which would match with the other planets. So the planet itself has had a lot more trouble with its naming than the moons did, but I do love that they went a literary route on naming the moons. And when they found it, like these things were so incredibly difficult to detect. When they first even found the whole planet, the entire planet Uranus, they couldn't tell if it was a planet or just like a comet flying by.
Oh.
And it took a while to even determine that it was a planet, because it was just this incredibly dim little tiny speck. It's 1787. So they're really,
Yeah.
straining the limits of the technical possibilities at the time when they found this thing. And now we know so much more about the system with just like one flyby and JWST.
Yeah.
It's crazy. I mean,
There
JWST
need
is doing amazing things, but I still think we should go back.
Oh yeah, yeah. I was just about to say that too. There, like Uranus and Neptune have been kind of neglected there have been missions to what is it, all the other planets and Pluto and comets and everything, but no one's returned to Uranus or Neptune.
Yeah, yeah. Well, and it's even Pluto got a mission before they
Yeah.
did. I mean, granted, it's not like a stationary orbiter mission. It did go on to other things. So, I mean, even Pluto got a flyby, I suppose.
Hmm.
Um, but yeah, there's just with all of these amazing, interesting, dynamic, icy moons and the chemistry out there just being so incredibly different than anything we're used to here on Earth. It's just an amazing potential for exploration and finding the unknown. Like you were saying about the carbon dioxide possible atmospheres, maybe if we could just get
Hmm.
there.
Yeah.
So really fascinating system.
Oh yeah, absolutely. So I'm definitely on the team of go back to Uranus and Neptune. I just wish some space agencies would listen to me.
Yeah, come on, it's just an orbiter. We can do it. And we'll talk more about space missions that and funding later on if we get to that news item. But anyways, speaking of what you can do when you actually get to go back to a planet properly and send an orbiter, let's talk about what we started off with on Jupiter. So you mentioned Uranus in 1787. So this was a discovery of two of the moons. But before, not quite 100 years, a good number of years before that, in 1610, we had Galileo's observations of Jupiter. 7 January 1610, Galileo made very detailed notes, so we actually know that it was, after date conversion, the 7th of January 1610, Galileo made an observation of some interesting things around Jupiter. He described, sorry, three bright stars, in quotation marks, close to the planet, aligned in the plane of the ecliptic, with two to the east and one to the west. So on the 7th of January, he had an initial observation of Jupiter with these three bright stars. By the 8th of January, he's watching Jupiter again. All three had moved from, well, two were on the east. All three had moved to the west by the 8th, so one day later. On the 10th of January, only two were visible, but again, on the east, not the west. Then a fourth companion appeared on the 13th and the 15th of January. So, fortunately, the orbital periods of what we now know as Galilean satellites are short. So they're actually very short. You can watch them go by if you have even a small telescope. It's super, super fun. And actually, I'm just going to take a break from the history part of this to tell any amateur astronomers who are out there, there's a very fun Jupiter moon tool that you can get to, and it's actually on our observers website as one of good tools to link to. This is not our tool; it's Sky and Telescope's tool. It's Find Jupiter's Moon interactive observing tool, and you can click on it, and it will show you where the moons are in real time, pretty much from your location if Jupiter is up for you. So it's actually quite fun. So that's the Sky and Telescope one. Galileo did not have this tool. All he could see was dots disappearing and reappearing in different places. So he had a strange phenomenon happening, and this was, I'm sure, super exciting to see something like this happening around Jupiter. It would have had a very, very small telescope, but even with a very small telescope, you usually can see that Jupiter is a disk, and then these dots disappearing and reappearing. Within a few months, Galileo was able to sort out the orbital motions. And that is a very good job with no tools, no Sky and Telescope moon tools or anything like that. He actually just did it by watching the dots disappear and reappear. And he was able to conclude that the inner moons had shorter periods than the outer ones. just like the planets going around the sun. And Kepler, around this time, laid out his third third law in his book was, and this is a little bit of a hard one to say because they were all writing in Latin, Harmonices Mundi in 1619. So in 1610, Galileo made these observations of Jupiter's moons. So he sorted out their orbital motions. He found the orbital periods, just like the planets. And Kepler demonstrated that his third law could actually be applied to the satellites of Jupiter as well as the planets in our solar system. When he wrote his book Harmonicus Mundi in 1619. So, in a very real way, this was a great scientific collaboration with Kepler and Galileo together. Um, Working, maybe not completely working together, but pretty close. And it was a really, really interesting time in history. And Galileo also had some naming trouble, I will just say, because he wanted to use his new discovery in honor of his patron, because as always, astronomy has not been well paid. So he tried to find wealthy patrons. He had the Duke Cosimo Il de Medici, and Cosimo would kind of be a cool name for a moon, but Galileo proposed to name the newly found satellites around Jupiter the Medician stars, so after the Medicis. His discovery and his proposed names for the planets were put in his book, Sidereus Nuncius, which has been translated a lot. It's the Starry Messenger, published in 1610. His proposed name for his patrons fared about as well as Herschel's. The other astronomers were like, no. So, following a suggestion by Kepler, um, he actually went with the names of Io, Europa, Ganymede, and Callisto, which came from classical mythology. Which were Jupiter comes from Jove, and so this was Jove's amorous conquests in classical mythology. So I don't know, probably better than Medicean stars. But yes, they did have even naming troubles with not just Uranus is the most famous, but even the moons of Jupiter had some trouble. And there was a little bit of joint discovery because around this time of 1609, 1610, telescopes started to become available. They evolved out of a sort of microscope contraption in the Netherlands. Galileo made some very substantial improvements to his telescope design, but other people were using them to observe the sky and actually finding the moons of Jupiter for themselves. In any case, if you do actually get a hold of translations of the old Sidereus Nuncius or other publications of the time, you will not see Io, Europa, Ganymede, and Callisto until much later. They were called Jupiter 1, 2, 3, and 4. They were called Medicean stars by Galileo. Different people who claim to discover them call them other things. So it's a bit funny, and it is Galileo's observations of the moons of Jupiter are actually a really fun project for anyone to do, even if you've just got, like, I don't know, little nieces and nephews or something in a small telescope. You can look through and you can watch the moons change their positions over just a couple days. So one of
It's
my favorites for sure.
oh yeah. Yeah, I remember even once with the 1 meter, you can see the moons if you get it at just the right time, kind of passing either in front or behind of Jupiter if you watch it for not too long. You just have to be careful with the timing.
Yeah, exactly. And if you, I mean, right now we do have some amazing fun tools. If you want to use your own favorite Jupiter moon tool or our favorite, which is the Sky and Telescope one, it'll tell you which moon is in which position. And just, 4 or 5 days is enough to get your own Jupiter moon orbits. It's very satisfying to see it working.
If
It's like,
only we
ah.
could get, yeah, if only we could get like 4 or 5 clear nights back to back, we could.
That would be a very good that's my New Year's resolution. Get 4 or 5 clear nights back to back. Let's do that. Let's do that this
Yeah.
year.
I agree with that. I like that.
So speaking of the icy outer solar system, there's another planet out there that we haven't talked about yet. You want to go ahead and take us to the next, well, the middle one.
Yeah, wonderful Saturn. So this is going to be in much more recent history in 2005, January 14th, which is when the European Space Agency's Huygens probe landed on Saturn's moon, Titan. Huygens was part of the Cassini-Huygens mission, which was joint between NASA and the European Space Agency. NASA contributed Cassini, which was a Saturn orbiter. It stayed in orbit around Saturn for many, many years, observing Saturn, its rings, and its moon system. And then Huygens kind of hitched a ride to Saturn with Cassini, detached from the Cassini spacecraft, and actually landed on the surface of Titan, which was the very first time that humans had landed something on the surface of a moon of another planet or something that far away from us. Because keep in mind how incredibly far away Saturn is. So it was a pretty significant mission, even just in terms of the history of space exploration. Now, in addition to that, this Titan mission was a really, really interesting one because scientists at the time didn't really know what to expect from Titan, and they really didn't know that much or weren't expecting too much about what Huygens would discover. So at the time, it was launched, I think it was about 7 years before it actually reached Saturn. And at that time, the only kind of in-depth observations that you had of Saturn and Titan and anything in the Saturn system was from the Voyager 1 and 2 probes. They both did flybys of Saturn, observed Titan while they were doing the flybys. And both of those missions kind of revealed Titan to be this orange, fuzzy ball. It had this really thick atmosphere and made primarily of nitrogen with some methane in there as well. Possibly had some organic molecules in the atmosphere, which made it a really, really interesting place to study and a kind of obvious target for a lander that was being sent to the outer solar system. There were also some radio observations that had shown that the surface could be solid. It also could have liquid methane or ethane on the surface in these oceans or rivers, but they didn't really know exactly what to expect. It could land on solid ground, it could land in a liquid ocean. So, to kind of get around this massive uncertainty about what they were going to find on Titan, engineers designed Huygens to be a very versatile probe. So one of the things that they had designed it was the ability to kind of touch down on any kind of surface. So it could survive touchdown on both a hard surface or a liquid surface. And on top of that, just to kind of make sure that the mission was successful, is they also designed the Huygens probe to be able to complete the entire mission with just the descent to the surface. It was designed to have a parachute connected to the Huygens probe, which would slow it down a lot after it entered the atmosphere, so that it would take this like nice leisurely 2.5 hour descent down to the surface of Titan. It would spend those 2.5 hours collecting data on the atmosphere, primarily things like the composition, the temperature, the wind, and even the weather on Titan. And then once it landed on the surface, if it survived the impact, that was great. It could continue collecting data and transmitting that back to Cassini, which would get transmit back to the Earth. But if it didn't survive the impact for whatever reason, then the mission would still be successful. Of course, all of this planning worked out, and Cassini successfully did land on the surface of Titan on January 14th, 2005. It entered the atmosphere at around 9 a.m. Universal Time on that day, took pretty much exactly 2.5 hours to get to the surface, and impacted at 11:38 a.m. It spent the entire 2.5 hour descent collecting and transmitting data, and then even continued to transmit data for around 3 hours after touching down on Titan. So again, this was a really significant sort of milestone in the history of space exploration, just because it was the first time that something like this had been done on a moon in the outer solar system. But it also revealed Titan to be this really like complex and very fascinating place in the outer solar system. So we don't have time to go into all of the awesome things that Huygens discovered on Titan, but just a couple of interesting highlights. Huygens was successfully able to determine the density and temperature profiles in Titan's atmosphere. It also studied things like wind profiles and haze in the atmosphere, and learned more about lightning on Titan and certain kinds of rain on Titan as well. It confirmed suspicions that the atmosphere is made primarily of nitrogen with some methane in there too. And it also learned about how Titan was able to get that methane atmosphere and also to maintain it. So it seems likely that Titan got that all of its methane while it formed. Some of that methane went into the atmosphere, but some of that methane, or a lot of that methane actually, ended up getting trapped underneath the surface. So it looks like there's this like really thick layer of ice, about 55 to 80 kilometers thick, that's trapping a ton of methane in this subsurface ocean on Titan. And some of this methane is able to kind of leak out to the surface and continue to maintain the amount of methane in Titan's atmosphere. The reason that that's kind of significant is because it first of all, it ruled out the possibility of microorganisms creating this methane in Titan's atmosphere. It would be super interesting if it had been microorganisms, but it's actually not. It's probably this liquid methane trapped under the surface. And it's also really interesting because methane can be destroyed by sunlight. So methane will only exist in an atmosphere of a planet or a moon for a certain given period of time before it kind of just dissipates and disappears because of this chemical reactions from light from the sun. So the methane does actually need to be replenished over time, and that methane on Titan is getting replenished from this massive subsurface ocean. In addition to a lot of discoveries about the atmosphere of Titan, the Huygens also took a ton of images of the surface of Titan. You should really check these images out. They're gorgeous. You see tons of these like rivers and channels and valleys that at the time Titan landed were empty, but it is also possible for those areas to flood and to actually have methane and ethane flowing on the surface of Titan, just like a lot of like liquid water flows on the surface of the Earth. Because remember, Titan is so cold, liquid water can't actually exist. It has to be ice. But things like methane and ethane, which have much lower freezing points, actually do exist in liquid form on Titan. So I think the discoveries from Huygens kind of made Titan one of the most interesting moons in the outer solar system. It definitely has a lot of promise, hopefully for some future missions, and it's just generally a really cool place in our solar system.
Oh yeah, literally and figuratively.
Yeah. Yeah.
uh, it's and it's worth noting that if you're familiar with the pressure temperature diagram from thermodynamics, once you go past below a certain temperature and pressure, your water behavior goes very, very much into the solid. It is not it is a solid rock at these extremely low temperatures. It is not a liquid, not even a relative of a liquid. It is a solid water rock. And it's just so, as you say, it's just so evocative because it came out that this is just such an interesting, dynamic, unusual place with bizarre chemistry and really, really literally and figuratively cool features that change. And it's, as you say, it's one of the most interesting moons for sure. It's the only moon with an atmosphere, a nice, thick atmosphere. Doesn't help keep it warm compared to Earth, but it does keep it warm enough that it's actually kind of maybe like early Earth was. It could be. And it's sort of been said that it's a bit Earth-like, but only if you can replace all of the things on Earth, which with much, much colder things. So the land would be made of water, ice. Rivers and seas are liquid methane and hydrocarbons. The air, such as it is thick and hazy, but the clouds are not water; they're methane clouds. And it's worth giving a shout out on this because we've been mentioning shout outs to JWST. After Cassini-Huygens, this was a huge, amazing, fabulous mission that was a super success, but we haven't gone back. It was expensive, and people started planning it in 1982, and it was kind of this gigantic one-off amazing mission. So in the meantime, last year, or no, not last year, the year before last, 2022, I think, was when JWST observed the clouds on Titan.
Yeah.
And they actually got something ridiculous, like 5 hours, 15 hours of JWST time. Yeah, it wasn't 5, it was 15. 15 hours on JWST watching clouds move across the surface of Titan. Um, Amazing stuff. Ah, so good.
Yeah. Some of these moons are just as interesting as the planets in our solar system. So a lot of
Well,
the moons are very,
yeah, much more walk-onable than
yeah. Yeah.
it was like, oh, if you're gonna go to Jupiter, you're not gonna go like to Jupiter, because radiation belts alone.
Yeah.
Um, you'd go to the moons, and I think that goes for Jupiter, Saturn, Neptune, and Uranus.
Hmm.
Of course, now we haven't talked about the most neglected one of all, which is still Neptune, but I'm not going to talk about it either. I'm
Poor
I,
Neptune.
poor Neptune is really terribly neglected. We'll have to do a Neptune episode at some point. What
Yeah.
little we know. Um, Actually, this is actually the point where I'll take a little break and remind everyone that you are listening to York Universe, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. You can find us online at yorku.ca/science/observatory, and you can check out all of our previous episodes as well as all of our fancy links to the YouTube or OPV online public viewing. For chats, questions, or content, you can see us here on YouTube or that website I mentioned before, or also on Twitter at York Universe and York U Observatory, as well as Facebook and Instagram. So tonight you're listening to Dr. Lena Hyde and Sana Withers. We're discussing the icy outer solar system and that it definitely should be explored more. um, and you are, if you're listening with us on YouTube, you're listening to the York Universe and seeing the OPV as well, the online public viewing with some lovely stock images taken by our very own telescopes. So, for the last little This Week in Space and Astronomy History, I thought I would round off with back to Jupiter. So, as you mentioned, in 2005, fairly recently, we had, of course, Saturn's amazing success. We did have a lot in between the 1700s, 1600s, and 2005. So I thought I would put a little intermediary exploration. Back when we didn't know too much about Jupiter, but we really wanted to, we had one of the first probes to go out, the Voyager 1, which we have talked about many times, I believe, on this show. It was launched in September 5 of 1977. However, on January 17th, 1979, so 1979, Voyager 1 was flying by and captured Jupiter. She captured an image of the planet Jupiter from a distance of 29 million miles or 47 million kilometers, so super close for solar system distances. And the photo returned on January 17th actually showed Jupiter's satellite Io passing in front of the gas giant, casting its shadow down on the planet. So it showed close up what Galileo had seen back in 1610 and inferred. We finally got a picture of Jupiter. We finally got to see it close up with the moon directly going around it, casting its shadow on the planet. So Voyager 1, of course, as a little reminder, this launched on September 5th of 1977. It flew past Jupiter. And of course, its actual flyby wasn't until March 1979, so it did get closer. As it was traveling through the solar system, it captured more than 18,000 images of the gas giant and its moons. Voyager's first pictures of Jupiter actually started when it was even farther away, 165 million miles or 266 million kilometers, and it started taking pictures right away. So it actually found a lot of interesting things as it was flying up towards Jupiter. So on January 17th, it was only 29 million miles. But even early on, it was able to see some strange stuff. It was able to see a thin ring circling the giant planet. So there was an actual ring of material going around Jupiter. It found two new moons as well. So two of the smaller moons of Jupiter, which have been named Thebe and Metis. And of course, Voyager 1 sent back detailed pictures of the Galilean moons, which were amazing to see. So this was Io, Europa, Ganymede, and Callisto. By this time, the names had been settled, so they were well and truly set in their ways of naming the Galilean moons. So the Theban and Metis came afterwards, but they followed the same pattern. So Voyager 1 has a lot to its claim to fame. It found volcanic activity on Io, which was showed for pretty much, I think, the first time that planets and moons can have active interiors. So moons can be active. And it was a big debate on Earth, or well, about Earth's moon, about what was the deal with the lava plains on our moon. How did that work? But Io showed volcanic activity in action. And finally, of course, Voyager 1 has kept going since then. And I'll just give it an extra shout out because in 2012, which is quite a ways, more than 10 years ago now, so 12 years ago, my gosh, Voyager 1 entered interstellar space. This was the first human made object ever to do so. And it is, let's see, the current distance counter is constantly changing, but it's now approximately 14.6 billion, so not million, but billion with a B, miles or 23 something something billion kilometers away from our planet Earth. So this is Earth's farthest spacecraft. It's zipping through space. It has accelerated for so long and gone so far that it's actually traveling at 38,000 miles per hour or 17 kilometers per second. It has a long way to go before it gets anywhere near the speed of light. But for an Earth-made craft, it seems to be doing very, very well. And of course, you can't say Voyager 1 without saying Voyager 2. So Voyager 2 was sort of the twin spacecraft, and it was actually launched before Voyager 1, but it reached Jupiter just afterwards. So of course, this was kind of the start of modern, shall I say, modern space exploration with satellites. The Voyager 1 and 2 probes showing what can be done even with just a flyby. Because for the first time ever, we got to see the volcanoes on Io. We got to see the moons casting their shadows down on Jupiter. We got to see, many, many, many firsts of, not just Jupiter, but also Saturn, and of course, Saturn's moon Titan. So Saturn's moon Titan had a flyby, and NASA had a choice of either doing Pluto or Titan all the way back with Voyager 1, and they chose Titan, which is probably why Titan got the awesome follow-up mission, Cassini-Huygens, all that time later. And of course, it's well out of its way, on its way out of the solar system. Unfortunately, not headed towards any stars. So for long, long ways, it's I think the nearest one is one of the more distant star groups. So it's a fun, a very fun little project, and of course the fact that we're still getting some data back once in a while is amazing as well. So Jupiter's
Yeah.
satellite Io passes in front of the gas giant, casting its shadow down on the planet. January 17th, 1979. Definitely a photo worth looking up.
Yeah,
Um,
I gotta say, I think they made the right decision going to Titan instead of Pluto, as much as I love Pluto.
yes. Well, it's Titan with a thick atmosphere and all that chemistry in there. It just and everything we've done with the follow up on Cassini-Huygens just made it so much more interesting as well.
Hmm.
I can't wait to see what they do next.
Oh yeah.
It's like
Yep.
more missions, and also I really want to see a submarine on Europa. But
Oh
um,
yeah.
there are infinite things to do, I realize, but there's some of them seem like it would just be the potential for exploration and learning new things is so incredibly high.
Hmm. Yeah.
Anywho, probably about time for our little reminders area. Just a couple little 2024 reminders. If you are interested in astronomy this 2024, I have some good news. The observatory regular in-person tours are back on. So due to the fairly early sunset, the tours are generally starting around 5:30 p.m. But the in-person tours at the Allan Carswell Observatory at York University are starting up this very week. So that is January 10th. The free tickets are on the website, and you can click on it and get free tickets. So please do that if you'd like to come by, so that we know you're coming. And our first Wednesday event, well, fingers and toes crossed for the weather. I It has been very bad, but even if the weather's bad, the tour will go on, unless it's like a blizzard, in which case we'll have to close. But we can still show you the inside of the renovated domes. There's also a little bit of fun extra astronomy. Do you want to talk about the new moon?
Sure. So this is an interesting new moon for 2024. It's the how do you say this? It's the kind of most extreme miss, the biggest miss of a total solar eclipse for 2024. So every month when we have new moon, it's when none of the surface that's facing kind of towards the Earth is illuminated by the sun. So it looks like we just can't see the moon in the sky because it's not reflecting any sunlight towards us. Of course, most of the time it does reflect a tiny little bit of sunlight towards us. We just can't really see that sunlight because it's so bright outside and the sun is so bright. Because if it was actually reflecting 0% sunlight back at us, it would create a total solar eclipse and fully block out the light from the sun. So most of the time, again, we can't actually see this. But the new moon coming up in this month on January 11th, so only a couple of days away, it will be the biggest or the most illuminated new moon of 2024. So it'll be the highest fraction of the moon that we could actually see from the surface that's actually illuminated towards us. Again, we can't see this because it's too bright outside and it's such a tiny fraction of the moon's surface facing the earth that's being illuminated, so we can't
Yeah.
see it. But it
And
is the
don't
most
look at the sun.
yeah.
um,
Oh my
it's
God.
it's very close to the sun in the sky. So whatever you do, don't look directly at the sun. It is extremely bad for your eyes. But you're right. This is going to be the largest distance between the sun and moon, the sun and new
Mhm.
moon.
Yeah. So it's an interesting event, but just not one we can actually observe.
Well, I think I would say this is an astrophotography challenge. If you have the right neutral density filters and appropriate eye protection, this might be the astrophotography challenge for you. Because it is going to be an unprecedentedly large distance away from the sun, which will be the biggest eclipse miss, as you say. It will be the most illuminated new moon. But this does mean also it's going to be the most illuminated, but it's also going to be very, very washed out by the surrounding lights. So I think the best case scenario is if this was in the sky and a cloud moved over the sun, but not the moon. And that would be
So
awesome.
so so we want clouds for
Just
once.
I just want a cloud over, or if you've got a piece of very, very thick black construction paper.
Mm.
You can, as I say, astrophotography challenge, putting it out there in case anybody wants to, with eye protection. So no damaged eyeballs, please.
No.
All right. So speaking of, we should probably go on to the news items. So we have some fun, chance to get into the colors of Uranus and Neptune, as well as a little bit of fun. So shall I do I kind of put the Vulcan launch at the top, but I'm happy to go first or second if you want to do yours first.
I can go second.
All right. So news items. This one's a little bit fun. So for those of you who hadn't heard, there was a Vulcan rocket launch. The space robotics firm Astrobotic. So we're not history anymore. This just happened. The space robotics firm Astrobotic Technologies Peregrine lunar lander successfully launched at 2:18 Eastern Time from Cape Canaveral, Florida, today, Monday, the 8th of January. That happened today, and it launched above on the first flight of Vulcan, which is an awesome name. It's a rocket that has been under development for a decade by Boeing and Lockheed Martin. This is a joint venture with the United Launch Alliance, which I had never heard of before this article. And it was the first ever launch. So the rocket launch happened successfully. Everyone was super excited. The lunar lander, this private space company lunar lander, was on its way to the moon. But hours after separating earlier today, they actually had some issues. So Astrobotic had some issues with the Peregrine's propulsion system, and it briefly prevented the spacecraft from angling itself towards the sun for power. So it basically lost a bit of power, and then while they regained control, the faulty propulsion system lost propellant. So they're right now, as of the last reading of the news updates, considering alternative mission profiles about how they're going to get the rest of the way to the moon. They got out of Earth, okay, so the Vulcan launch actually worked very well. So the launch of Vulcan was a 200-foot or 60-meter tall rocket. So that's pretty tall. The engines were made by one of the many private companies that are trying to get up and running. So this was the Jeff Bezos Blue Origin company, and they made this rocket. And this was a crucial first for this United Launch Alliance. So we might be hearing more from them soon. They developed Vulcan to replace the Atlas V rocket, and they are hoping to create a rival for the reusable Falcon 9 from Elon Musk's SpaceX. And the reusable Falcon 9 has been doing amazing. A real shining star, I suppose. I don't know how not a star. That's Starlink. But it is a pretty interesting one, and the Falcon 9 has proved itself as a launch launching option. This one had not, but it worked perfectly. The rest of the lunar lander did not, but the launching worked well. And it was actually surrounded by even more controversy than usual because this launch was a private launch and they weren't just sending a lander to the moon. They were sending a lander with customer paid for DNA and cremated human remains.
Oh,
This included DNA of 66 mission quote unquote participants whose remains would be permanently situated on the moon's surface following the Peregrine's landing. So this actually provided quite a bit of controversy. They have a lot of other things that they have sent in this rocket. I encourage everyone to go and read through the extremely eclectic list. But it was really the human remains that were sort of like, actually, are we sure we want people to be able to bury themselves on the moon? Um, and it might be a moot point because maybe it won't um, get there, but it's already been launched and it's actually already on the way to the moon. So if it lands, is this something we want to let people keep doing? Is the question. Anyways, very interesting stuff and very interesting mission. So in the news as of today, I don't know how it will end, but it's worth checking up on tomorrow to see where they are.
yeah, I guess this is one of those, they'll do whatever they want because there's no one to stop them. Sort
Well,
of
we have space lawyers. I mean, there's a space law profession. Um, so yeah, there's anywho, we should probably go on to the end with a little bit of extra Uranus and Neptune news because this gets us back to the icy outer solar system.
Yes. So back in 1989, when Voyager 2 did its flyby of Uranus and Neptune, NASA released pictures of Uranus and Neptune as imaged by Voyager 2. The Uranus image of Uranus has it looking sort of like a pale whitish kind of blue, but Neptune in these images actually looks like a very, very deep blue. And ever since then, I think myself included, most people have kind of thought of Neptune as a dark blue and Uranus as a sort of whitish light blue. But it turns out that this is actually not the true color of Neptune. The images from NASA mostly got the image of Uranus right, but not Neptune. They had to kind of enhance the images of Neptune to bring out a lot of detail in the atmosphere. So things like storms and some almost banding on in the atmosphere of Neptune. But in doing that, they also kind of artificially made these images of Neptune a little bit too blue. They were upfront about this when the images were released. They warned everybody, hey, this is not the true color of Neptune. But I guess people just don't read the captions to a lot of these images.
Yeah, once the picture
So,
gets out there,
yeah. So everyone has kind of just accepted that Uranus is light blue and Neptune is dark blue. But a group of researchers who are actually studying the seasonal variations of the color of Uranus and comparing them to the color of Neptune kind of highlighted that actually Neptune is not dark blue. It is has a very similar color to Uranus. Uranus is a bit of a whiter, paler blue than Neptune, but overall the two are very, very similar shades of blue. So I guess we're finally giving Neptune a little bit of well-deserved attention where it is not as dark blue as everyone has kind of believed it is. It is a lighter blue. And the researchers who have kind of made this discovery, or I guess it's not a discovery, but have been highlighting this for everybody, have released new reprocessed images of Neptune, which show it in its true color. They've also released an algorithm that's capable of processing a lot of these Voyager 2 and Hubble Space Telescope images to give the true color representations of the planets. So definitely, I think pretty interesting. I didn't realize that Neptune was as light blue as it was.
yeah, absolutely. And it is worth noting that a lot of astronomical images you see are not true color. They are heavily processed, or they're processed so that all the oxygen shows up as green, which oxygen does not immediately shine green. Like that's
Yeah.
that's an artifact that we have put into our images to make that scientific thing pop out so that it's more measurable.
Hmm.
But reprocessing science images for true color is absolutely worthwhile, especially if you're making public images, because a lot of times on a public image, people won't necessarily, see that that's not the real color, right?
Yeah.
This is a photoshopped image, basically, designed for scientific analysis and not human eyeballs, or designed maybe to bring out certain effects so that it looks more spectacular. You can see the gas lanes. Um, but yes, I think this is a very, very cool thing. And I will note that a lot of the images online have actually been recently replaced. So if you do a Neptune search,
Mm.
you should see some new ones.
Oh, yeah. That's pretty cool.
Excellent. All right. Well, I think that's all the icy outer solar system fun we have time for today. We better wrap up everything here and say thanks to everyone. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the faculty, alumni, and friends of York University. The hosts this evening have been Sana Withers and myself, Dr. Elena Hyde. And you can always connect with us on Twitter or Instagram or Facebook at Allan Carswell Obs or York Universe, York U Observatory. Check out our website for show notes, content, and updates at yorku.ca/science/observatory. Thanks for tuning in to York Universe, clear skies, and have a good night.
Have a good night.